Hi, I'm Peter Marrocco, and I'm doing the Repressible Operon. An operon is a segment of DNA that has one promoter for multiple genes. And right here, this is the structural genes. They're usually composed of 3 genes, and they code for the protein. Right here is the promoter. This is the location where the RNA polymerase attaches. And right here is the operator. This is the site for binding regulatory proteins. And right here is the regulatory gene. This can code for a repressor, or in this case an inactive repressor. And right here, this is a repressible gene, repressor protein. This binds to the operator and blocks RNA polymerase to attach to the promoter. And right here is the mRNA. This is the major way gene expression is controlled. Okay, so the repressible operon is usually turned on, and that means it is negatively controlled. It usually codes for an anabolic pathway, which is building onto. It can be turned off if the product it builds is in excess, which basically means it's turned off by negative feedback. Okay, so let me start off by having the RNA polymerase, which transcribes structural genes and then later begins transcription and produces the mRNA. Starts off by binding to the promoter, moves across the operator, transcribes these genes, and the structural genes code for a protein, and this is seen as a inactive repressor because it can't fit into the operator, and so this will be activated allosterically by the co-repressor, which is this, and fits into the regulatory gene and changes the shape so it can form or fit into the operator. So let me get this, put it in the operator, and this turns off the operon. So when the RNA polymerase again attaches to the promoter, tries to move along, it is blocked by this protein. And so when it's turned back on, this co-repressor falls off, which later results in this repressor protein to fall off. And again, the RNA polymerase can go across and transcribe and begin transcription. Thank you for listening. I hope you learned a lot.